This is a basic question. In the case of conservative force, work done in the closed loop is positive. No, you know it will be 0. So this is false. Work done in a closed loop is negative. No. This is another false statement. Work done is dependent of the path. No. It is independent of the path. You know. If I go for option number 4, work done against conservative force is stored in the form of potential energy. Yes, this is true. So this is a basic question I would like to repeat. So my option number 4 will be the right choice. Let's move on. Question number 37. In the question number 37, a force 2x 3j 3z square k cap Newton is acting on a particle of mass 2 kg, which is displaced from point A 230 to point B 321. The work done by the force on the particle will be. In this type of question, I would like to suggest you will use the formula first Fxi cap plus Fyj cap plus Fzk cap with the dot product of dxi cap, dyj cap and dzk cap. So Fx, x component of the force along x-axis, that is 2xi. So when you will take dot product, I dot I is equal to 1. So you will get 2x dx. Similarly 3 dy plus 3z square dz. And now I'm going to concentrate the points A to B. So these are limits. In the case of x1 and x2, you will write from 2 up to 3. In the case of y, 3 to 2, 3 to 2. And in the case of z, we'll start from 0 up to 1. So 0 up to 1. So when you will integrate, you will get x square by 2, 2 up to 3 plus 3y, 3 up to 2 plus 3 z cube upon 3, 0 up to 1. When you will solve this type of integration, you will get 5 minus 3 plus 1. On solving, you will get plus 3 joule. So my option number 2 will be the right choice. So let's move on. Question number 38. In the question number 38, the potential energy of a particle of mass 2 kg moving along x-axis is given by 4x square minus 2x cube, where u is in joule and x in meters. The kinetic energy of the particle is maximum at. Because as per the law of conservation of mechanical energy, if kinetic energy is maximum, this is possible only if potential energy is minimum. So this idea and this concept will give you an idea that you can use maxima minima concept. So I am going to differentiate the expression of potential energy. 4x square minus 2x cube. So when you will differentiate, you will get 8x minus 6x square. If u is minimum, then we can write this is equal to 0. So 8x is equal to 6x square. X will cancel. So I have x equal 8 by 6 or 4 by 3 in general. But in this stage, we are unable to decide the point. So this is very good question. Now, if I differentiate again, second derivative, we'll get 8 minus 12x. Now we'll see what I'm going to. If I place x equal to 0, suppose, because this expression will indicate, you can put x equal to 0 and x equal 4 by 3 for checking your answer. So if I put x equal to 0, we'll get 8 minus 0 and that will give you positive value. And if the second derivative of the potential energy you will get positive, then you can say potential energy will be minimum. Okay? Now, but if I go at x equal for your satisfaction 4 by 3. So now I am going to place the value 8 minus 12 into 4 by 3. 3 4 ja 12. So that will give you minus 8. This minus sign will indicate potential energy will be maximum if you will use 4 by 3. So what are the conclusion? Conclusion is that at x equal to 0, potential energy will be minimum, then kinetic energy will be maximum, but at x equal 4 by 3, potential energy will be maximum, so kinetic energy will be minimum. But question is asking to us, the kinetic energy of the particle is maximum at. So this is possible only when you will take x equal to 0. So by this discussion, I can say my option number 1 will be the right choice. So let's move on question number 39. In the question number 39, a block of mass 4 kg is released from the top of a rough inclined plane. Height is 10 meter. If velocity of the block at the bottom is 10 meter per second of the incline, then work done by the friction force on the block will be. In this type of question, I would like to suggest you will use work energy theorem. So here work done by the friction force will be equal to final mechanical energy minus initial mechanical energy. This one, work energy theorem. So final mechanical energy, block will have kinetic energy half mv square plus 0 potential energy. Why I am saying 0 potential energy? Because if I take, this is our reference point at the ground level, so there is no height, so there is no potential energy, and minus at initial level there is no speed, so I can say there is no kinetic energy, plus, but block will have a height 10 meter, so the potential energy will be mgh, and m is 4 kg and g is 10, height is 10. So I have this expression. If I put the value 1 by 2, mass is 4, velocity speed of the bottom is 10. So 1 by 2, 4 into 10 square minus 4 into 10 into 10. So you will get a simple calculation. On solving, you will get minus 200 joule. So that will indicate your option number 3rd will be the right choice. So let's move on question number 40. A ball strike a horizontal floor at an angle 30 degree from the normal, just like this. Angle is 30 from the normal. So we'll see, this angle will be 30. If I resolve the component, so this is V cos 30 and this is V sin 30. When it will strike, if I take, because this is tangential axis and this one is normal axis. You know from the concept of oblique collision, there is no change in velocity along tangential axis if surfaces are smooth, and the velocity will change along normal axis only. So when it will reflect, you will get two component of velocity. In this situation, if I write by v dash, then that will give you e times of initial velocity or velocity before collision. Here the meaning of u is that the velocity of the ball before collision, and velocity along tangential axis will not be changed. So that is v sin 30. I need resultant velocity. So if I go this, v vector v is e u and plus v sin 30 with the square root, because I am looking to find the magnitude. And I would like to repeat, u is velocity of the ball before collision, and you know very well the value of u is none other than, that is v cos 30. So when you will take the square and put the value of coefficient of restitution, that is 1 by 3. So we'll write 1 by 9 plus v square cos 30 is root 3 by 2. So that is 3 by 4 and plus v square by 4. When you will calculate this value, you will get v upon root 3. So this is the final speed. Now, because question is asking to us the percentage of its kinetic energy lost in the collision is nearly. So for the loss of kinetic energy, I will write final kinetic energy minus initial kinetic energy divided by initial kinetic energy, and for percentage multiplied with 100. So that is what I am trying to solve. Final kinetic energy is given by half and final speed v by root 3. So v square by 3 only. Then you will take root. Initial kinetic energy half mv square. If I take the speed is v and divide by half mv square whole multiplied with 100. So you can see half mv square, half mv square, half mv square will cancel out and you have only 1 by 3 minus 1 into 100. So when you will solve, you will get minus 2 by 3 into 100. So that will give you 66%. Minus sign will indicate the loss of energy. So my option number 4 will be the right choice. So let's move on question number 41.